Hello class, today we're going to go ahead and start section 2.3 and 2.4, which is slope and writing linear equations. Your learning target for today is to be able to find slope, rate of change, and write linear equations. So let's go ahead and get started. The grade of a road is a percent that measures the steepness of the road. It is found by dividing the amount the road rises by the corresponding horizontal distance. So it's divided by how much it rises and the horizontal distance. Sometimes we refer to that as the run. So the rise over the run. So the steepness is equal to the rise over the run. You guys know something else that refers to rise over run, and that is slope. So slope, the slope of a line is the ratio of the change in the y coordinates to the change in the x coordinates. The equation for slope, remember m is the letter we use to represent slope, but the equation is y2 minus y1 all over x2 minus x1. Another way we can write this is delta y over delta x. What that means is it is the same as the change in y over the change in x. And delta is a symbol that you will learn a lot more as you get into advanced math classes. So let's just look at some basic equations of lines. Looking at this box here. So if the line rises to the right, then the slope is positive. So notice this one, as you read from left to right, it goes higher. So that means that it is positive. This next one, 0. As you go from left to right, you're not increasing at all. So it is a slope of 0. If it falls as you look from left to right, that is a negative slope. And if it is straight up and down, there is no slope. It is undefined. Okay, and I want you to remember that an undefined line, the equation, notice your x value is exactly the same for both. So this is actually the equation x equals -2. Using that same kind of idea, if we look back at our line with a slope of 0, notice they both have 2. Well, that is your y variable, so it's y equals 2. That's the equation of the lines. Some other important facts. Lines that have the same slope. Well, if you look at these two lines, you can tell that they are parallel. They will never touch. And also, that means that the slopes are the same. So what we say is the slope of the first line is equal to the slope of the second line. And if we go ahead and look at the next one, you can notice they are perpendicular. They're meeting at a 90-degree angle. So these are perpendicular. A little bit of geometry from last year. One way to write that is the slope of the first line. To do the opposite, you make it negative. Reciprocal, you put it over a fraction, so 1 over. Another way to check to make sure you have the right slope is if you take the slope from the first line, multiply it by the slope of the second line, you should get -1. Let's just quickly look at an example. If I have a slope that is 3 over 2, okay, my perpendicular slope, well, I would do the opposite, so make it negative, and the reciprocal will be to flip it, so 2 over 3. And let's look at one more example really fast. If I have a slope that is -2, okay, well, the opposite, this one's negative, so now it's positive, and then the reciprocal, well, it's 2 over 1, so it's positive 1/2. Those are your opposite reciprocals. Let's go ahead and look at example 1. Find the slope of a line that passes through the 2 points. Okay. So part A, my slope is equal to my y2 minus my y1. So -2 minus 4 all over my x2 over my x1. So 1 minus a -1. And if I go ahead and simplify, this will give me -2 minus 4 gives me -6 all over 2. And simplify one more time and I get -3. So for those 2 points, my slope is equal to -3. I would like you to now pause the video and I would like you to do part B on your own. Now example 2, we're going to go ahead and graph the line with the given coordinates. Well, Part A says it has a slope of 1/2 and it passes through the point 2, -1. So I plot my point 2, -1, and then my slope is 1/2. So it means I'm going to rise 1, run 2. So rise 1 over 2. So rise 1, run 2. Or you could do the opposite. Fall 1 to the left 2. Fall 1 to the left 2. And so there is my line. Okay. Once again, I would like for you to pause and do example B on your own. All right, so rate of change, that's one thing I said earlier when we were talking about slope. So it measures how much a quantity changes on average, relative to another quantity oftentimes. So time, just so that you guys are aware, time is usually x. Okay, and so when we have an ordered pair, it's usually time and then whatever other value we are talking about. So it's just important to know that rate of change is the same as slope, and typically it's over time. So let's look at an example. Example 3, use a table that shows the temperature at different times on the day. What is the average rate of change? So when they're asking for average rate of change, they're really asking for the slope, same thing, of the temperature from 8 a.m. to 10 a.m. Well, if we look at 8 a.m., the temp is 36 degrees Fahrenheit. Notice my time is my x value, and at 10 a.m. it is 47 degrees. So I go ahead and I would find the slope or the rate of change. They are the same thing. So 47 minus 36 all over 10 minus 8. So when I go ahead and do that, I get 11 over 2, which gives me 5.5, and then my change. Well, my y values are in degrees Fahrenheit, and this is in time. So my label on this is 5.5 degrees per hour. So it means it's increasing 5.5 degrees per hour. Okay, let's go ahead and look at part B. What was the average rate of change of the temperature from 12 p.m. to 4 p.m.? Well, same thing. So at noon, so at 12, it was 55. Now here's the thing you need to be careful of. If I use 4 again for 4 p.m., that's not going to be right. So we need to use military time. So I would do 12 plus 4. So military time would be 1600 hours. So it is, we would just use 16 because it's the 16th hour of the day. So 16 and 60. Finding that rate of change, I would do 60 minus 55 all over 16 minus 12. So I get 5 over 4, which gives me 1.25. And once again, I label. This is going to be the same, degrees per hour. So it's increasing only by 1.25 degrees per hour right now. Okay, part C. During what 2-hour period was the average rate of change of the temperature the least? Okay, well, in order to do this, we can go ahead and look at our table. If we look in here, from here to here, there was 2 hours in between. Once again, 2 hours in between here, 2 hours in between here, and in between 2 to 4, there was also 2 hours. So the change in all of these is the same. Now we just need to figure out, well, how many degrees change was it from each 2-hour period? Well, from 36 to 47, it changed. It went up 11 degrees. From 47 to 55, it went up 8 degrees. From 55 to 58, it went up 3 degrees. And from 58 to 60, it went up 2 degrees. So you go ahead and you look, well, which one had the least change? Well, that would be from 2 to 4. So that would be from 2 p.m. to 4 p.m. And make sure we label if it's a.m. or p.m. All right, let's go ahead and look at example 4. It'll be a last example for today. Kevin's savings account balance changed from 1,140 in January to 1,450 in April. Find the average rate of change per month. Well, once again, I have 2 ordered pairs. We always put time as our X, and so our time is January. January is the first month of the year, and you have 1,140. And to April, well, April is our 4th month of the year, and you have $1,450. But we want to know the rate of change, so once again, we just need to find the slope. So I would do my y2 minus my y1 all over my x2 minus my x1. 1,450 minus 1,140 gives me 310 divided by 3. And if you calculate that out, that gives me 103.33, so $103.33. And I need to figure out the label. Well, the top is dollars and the bottom is the month. So it's 103 and 33 cents dollars per month. It went up that much each month. Okay, we're going to go ahead and stop the video there for today. Make sure you do the video quiz and have the notes all the way done for class tomorrow, and have a good day.